All right, today we're tackling a tool that's kind of the secret engine of the modern web, Selenium WebDriver. If you've ever wanted to know how to automate a browser, we're going to break it down from square one all the way to writing your first script. Let's jump right in.
You ever stop and think about how a site like Amazon or Google can change stuff every single day and it just works? I mean, they're not paying thousands of people to sit there and click every single button, right? No way. They have this army of digital robots testing everything around the clock. And the general leading that army, more often than not, it's a tool called Selenium.
So, what is Selenium? At its core, it's a free, open-source tool that lets you control a web browser with code. Just think of it like a remote control for Chrome or Firefox that you can program. Its main job? To run automated tests over and over to make sure everything on a website works exactly the way it's supposed to. Okay, so to really get this, we're going to follow the life of a test script from start to finish. We'll kick things off with the setup, then we'll figure out how to find our target on the page. After that, we'll actually do something, then deal with the chaos of the real-world web. Then comes the moment of truth, the verdict. And finally, we'll talk about how to take this from one script to a whole bunch. So, first things first, our journey starts with a really basic but kind of magical step, popping open a browser window. But, not with your mouse. We're going to do it with code. If you're using a language like Java, it's basically a two-step dance. First, you have to tell your code where to find this little helper file called a driver. It's unique for each browser. Then, you just create a new WebDriver object. You run that single line of code and boom, a brand new, clean Chrome window just appears on your screen, ready for you to tell it what to do next. It's pretty cool. All right, the browser's open, so what's next? Well, right now, our script is basically a blind robot you just dropped into a strange room. It has no idea where anything is. We have to give it a map so it can find stuff, like the search bar or that big login button. And that map, in the world of Selenium, is called a locator. It's really just an address that points to one and only one thing on a web page. It's a perfect analogy, really. A street address gets you to a specific house. A locator gets your script to a specific button or input field. And you've got options for how you write these addresses. You can find things using a unique ID, a name, or a CSS class. If you're trying to find something in a really tricky spot, you've got these super powerful tools like XPath or CSS selectors that let you navigate the page's code. But here's the key thing to remember. You want something stable. An element's ID is like its fingerprint. It's unique and the most reliable. Using something like the text on a link, well, that text might change tomorrow, and poof, your script is broken. Okay, so we've got the browser open, and we've pinpointed our target. The next step is, well, to actually do something. This is where the magic really starts to happen, and our script stops just looking and starts interacting. Probably the most common thing you'll do is type stuff into a box, and for that, there's the send keys command. It does exactly what it sounds like. You just tell Selenium, hey, see that text box over there? And then send keys will type whatever you want right into it. It's literally the script's keyboard. Now, this is a super important distinction. How you tell Selenium to find something matters. If you're just looking for one thing, like the submit button, you use find element, it'll find the very first thing that matches your locator and stop. But what if you need to grab, say, all the product names on a search results page? That's where you need find elements. See the S at the end? That one gathers up every single match and hands them to you in a nice, neat list.
Yeah, in a perfect world, every website would load in a split second. But we don't live in that world, do we? The real web is messy. Pages are slow. Things pop up. Elements take a few seconds to appear. Our script can't be dumb about this. It has to be smart enough to handle the real world.
The trick is to teach our script to be patient. We do that using something called waits. The simplest one is an implicit wait. It's like setting a general rule. Hey script, for anything you're looking for, just wait up to, say, 10 seconds before you give up and throw an error. Then you have the explicit wait. This one's more like a sniper. It's super precise. You tell it, I want you to wait only until this specific button is clickable and not a millisecond more. And then there's the fluent wait. This is the pro tool. It does what an explicit wait does, but you can also tell it how often to check, like check every 200 milliseconds. This is awesome for super dynamic pages where stuff is flickering in and out of existence.
All right, so your test is done. Now you got to clean up after yourself. And this is a classic mistake almost everyone makes at first. If you use driver.close, it's only going to close the one window or tab your script is currently looking at. But what if your test opened a pop-up or a new tab? Those will just be left hanging. To kill everything, the whole session, and every single window it opened, you need to use driver.quit. Super important difference. So how do you even manage all those different windows? Well, Selenium gives every single window a unique ID, which it calls a handle. Think of it like a name tag. If you just need the ID for the window you're on right now, you use getWindowHandle1. Simple. But if you're juggling multiple windows and need to switch between them, use getWindowHandles, again with an S, and it gives you a whole set of all the IDs so you can hop from one window to another.
Okay, so our script ran, it opened the browser, it clicked the button, it typed the text, it closed the browser. Great. But did it work? Did the thing we expected to happen actually happen? How do we get the final verdict? Pass or fail?
This is where we check what we expected to happen against what really happened. And you've basically got two ways to do this. First up is assert. Think of an assert as a total showstopper. It asks a question like, does the page say login successful? If the answer is no, the test just halts. Bam. End of story. Test failed. Then you have verify. This is more like a fact checker. It asks the same question, but if the answer is no, it just jots down the error in a log and lets the rest of the test keep on running.
Look, things are going to go wrong. It's just a fact of life. Your script is going to crash and throw these errors, which in programming we call exceptions. You're going to see no such element exception a lot. That just means your locator didn't find anything. Element not visible exception means the element is in the code, but you can't see it. The stale element exception is a weird one. It means you found an element, but then the page refreshed or changed, and now your reference to it is stale. And timeout exception is easy. Your wait just ran out of patience. The important thing is not to get frustrated. These errors are your friends. They're like road signs telling you exactly where to look to fix your script. So writing one little script is cool, and it's a great start. But in the real world, you're not writing one script. You're managing hundreds, maybe thousands. So how on earth do you keep all that organized? Well, that's when you level up from just a script to what's called a test suite.
First thing you learn, you absolutely do not want to hard code those locator addresses directly in your test scripts. Just think about it. If a developer changes the ID of a button, you'd have to go find and fix it in, 50 different files? No thanks. The smart way to do it is with an object repository. It's just a fancy name for a central place, could be a simple file, where you store all your locators. That way, your scripts all look to this one file for the addresses. If something changes, you fix it in one place. It's a game changer for maintenance.
And to organize everything at a large scale, people use standard patterns called frameworks. You've got a few popular types. A data-driven framework is great for when you want to run the same test with tons of different data. Like imagine testing a login form with 100 different username/password combos from a spreadsheet. A keyword-driven framework lets you build tests from reusable keywords. And then there's behavior-driven development, or BDD, which lets you write tests in plain English so even non-tech people can understand them. In reality, most teams use a hybrid model, kind of cherry-picking the best ideas from all of them.
So we've seen all this incredible power. Selenium can drive a browser, click things, type things, check things. It really seems like a superpower for the web, which leads to a really interesting question. Are there any limits? Can it literally automate anything you throw at it? And the answer, surprisingly, is no. A very deliberate no, actually. Selenium was specifically designed so that it cannot beat CAPTCHA. You know, those I'm not a robot puzzles? Think about it. The entire purpose of CAPTCHA is to block bots and automated scripts. Well, Selenium is an automated script, so it gets blocked on purpose. It's a great reminder that this tool is for testing, not for trying to get around a site's security. And there you have it. That's the whole journey, from knowing nothing to understanding the pieces of your first script. You've got the building blocks now. You know how to launch a browser, find things, click on them, and check the results. So I guess the only question left is, what are you going to automate first?